Sets. A set is a list or collection of elements that share a characteristic. So, what do you mean by this? So, a set is a list or collection or group of elements, stands for objects, that share a characteristics. Means we are collecting a group of objects which have a particular characteristic, a particular order. Such group or collection or list is named as sets. For example, set of vowels. Set of vowels is an example for set because it share a characteristic. It shows us a characteristic, isn't it? Set of primes less than 10. It shows us a characteristic. Yes. Like what we can say, another one example. Set of days in a week. So all these are a group of objects or elements which share a particular characteristic, which shows a particular characteristic. Like set of vowels shows a particular characteristic. So we can write the elements as A, E, I, O, U. What are the set of vowels? A, E, I, O, U. Okay. Set of primes less than 10 is 2, 3, 5, 7. Set of days in a week: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Now, when you write these sets, you have to enclose these elements with a curly bracket. Okay, so you have to enclose the elements with a curly bracket. So a set is a list of elements separated by commas and enclosed in a curly bracket. There we get the definition of a set. So a set is a list or collection of elements that share a particular characteristic. Lowercase letters are used to write the elements. Like when you make a set, inside the curly bracket we write the elements. If you write the elements as alphabets, we use lowercase letters like A, E, I, O, U. And to name this set, we use a capital letter. So we can name it as set A is set A, E, I, O, U. Okay. And another thing is, I'm writing one example. Write the set of elements presented in the word happy. Okay. So when you write the set of elements, it's very simple. You write the set with elements H, A, P, Y. Oh, did I miss anything? Yes, you think one P is missing now? No. Here P is repeating twice, isn't it? So when an element is repeating more than once, write it only once here. Okay. Don't write the elements repeated. That is another rule for set. Now let's discuss about a few types of sets. So first type is finite set, second is infinite set, third is empty set, and fourth is singleton set. So what is finite set? It's nothing but a set which has countable number of elements. If a set has countable number of elements, we called such a set as finite set. It's vowels. Vowels are finite set, isn't it? Vowels are finite set. Okay, so what is finite set? A set which has countable number of elements. Example, we can give the example as vowels. Tell me some examples, like set of primes less than 10, set of even numbers less than 100, set of natural numbers from 1 to 100. All these are finite number of sets because there are countable number of elements. So you think more examples about it. Okay, now infinite set. So what are infinite set? Yes, a set which has infinite number of elements. A set which has infinite number of elements. That means no count for number of elements. Uncountable number of elements can be called as infinite. What are the examples we can use? Nothing. The set of natural numbers, set of whole numbers, set of rational numbers, set of integers. All these sets have infinite, uncountable number of elements. Such type of sets are known as infinite set. What if a set has no element in it? I got no element in it. Such sets are known as empty sets. A set which has no element in it. You might be surprised. Is there any set without any element? Let's see. Just find a set of odd numbers which are the multiples of 2. Can you write set of odd numbers which are the multiples of 2? Is there any odd number which are the multiples of 2? No. No odd number multiples of 2, isn't it? So we can say this set, if you make this set, it has no element in it. Such type of sets are known as empty set. Empty sets are also known as null set or void set. Empty sets are also known as null set or void set. Void. And this is the notation we use for empty set. What is this? A circle and a cut. It is not a circle and a cut. It is a Scandinavian alphabet. What alphabet? Scandinavian alphabet, which is phi. Phy, phi. Pronounce it as phi. Just pronounce phi. Okay. Even you can use this one also to denote an empty set or null set or void set. So the common notation of empty set is this one. We use this notation. So it's nothing but just a circle and a cut. Okay. If a set has only one element, a set has only one element in it, just one element in it, then we can call such a set as a singleton set. From the name itself we can understand singleton set. Set of even prime numbers is an example of a singleton set. Just remember which is the even prime number. If you think about even prime number, there is only one even prime number, that is 2. Number 2. Only 2 is even prime number, no? So if you make a set with set of even prime number, it is set 2. How many elements are there in this? Yes, only one element in it. Okay, so we can call it as a singleton set. Okay, like if you write an empty set like a dot in that, you are writing empty set like this, and by chance you just put a dot in it. Now this is not an empty set, it is a singleton set because there is an element in it. Element can be object, element, alphabet, letters, or symbols. Anything can be elements. So don't put anything in that. If you put just a dot or comma, anything in the curly bracket, it will be converted to a singleton set. Okay. Now look at these signs. Have you seen these symbols anywhere? You might have seen these symbols. So what these symbols represent? Okay, here the first symbol, you see it looks like a E. It's not E, just look like a element E, a letter E. And it has the same meaning of that. E stands for element of. What? Element of or belongs to. We'll say now 2 is an element of even numbers, set of even numbers. 3 is an element of set of odd numbers. Yes, just we use such words. For that we use this one element of. So from this we can understand what is this. It is not an element of. What is that? Not an element of, or it does not belong to. Okay, like 3 does not belong to set of even numbers. Does 3 belong to even number? Does 3 is an element of? Do 3 is an element of even number? No. Okay, let's make one example. I am writing a set. Set A is 1, 2, 3, 4, 5. Okay, now if I write 3, if I take an element 3, we can say 3 is an element of A. So we write 3 is an element of A. We can read it as 3 is an element of A, or we can read it as 3 belongs to A. 3 belongs to A. Okay, but if I take an element 6, you don't find 6 in this. That means 6 is not an element of A, or 6 does not belong to A. Universal set. It is a set contains all possible elements in it. So what is it? It is a set which contains all possible elements that you would consider for a set in a particular problem. So in a particular problem, what are the elements required? So in a particular problem, what are the elements required to form a set? So all those elements are taken together to form a new set known as a universal set. Like suppose I'm making a set 1, 2, 3, 4, 5, 6, etc. up to 10, and I frame a new set which is set 2, 4, 6, 8, 10. So to frame this new set, we have taken the elements from this original set. Yes. So this set is considered as universal set. Okay. And universal set is denoted with this symbol. This is also a symbol we can use for universal set. Okay. Complements. The complement of a set is the set of all elements which are in universal set but not in the given set. For example, complement of A. Suppose A is a set. Then complement of A contains all the elements of universal set which are not in A. You may get confusion. Let me show you. Let's take a universal set. Set 1, 2, 3, 4, 5, 6. And suppose A is set 2, 4, 6. Okay. Then complement of A. Complement of A can be denoted by A complement. Just A to a power C. You have to read this one as A complement or A complement with a dash. Okay, is the set of elements which are from universal set but not from A. That means in a very simple way, delete all the elements of A from the universal set. So if you delete 2, 4, 6 from this, what is remaining? 1, 3, 5. So form that set. Set 1, 3, 5. Did you get how to make complement set? So this is known as complement of set A. Suppose set B is 1, 2, 3. Then what's the complement of B? 1, 2, 3 we have to delete. That means from universal set, delete 1, 2, 3. What is remaining? Set 4, 5, 6. That is known as complement of set B. So here we can make a general definition as, if A is a set, then its complement, A complement is universal set minus A. B complement is universal set minus B. C complement is universal set minus C. Here minus stands for delete. Okay.